This lesson is a very brief introduction to machine code, assembly language, and the levels of programming languages. This is needed for the next section of the course, and this is a little bit of a recap of GCSE. For your first task, I want you to watch this quick video. Now, I'm going to keep referring back to this diagram. This is the different levels of programming languages. At the top you have high-level programming languages, and at the bottom you have machine-level code and binary. In between that is assembly language, and this is what we're going to have a quick look at today. Now, high-level languages are languages like Python and C, but we need to have an understanding of machine code and assembly language. So machine code is basically binary. Binaries are 0 or 1 bits of data, and that's the only data that a computer can understand. Now, machine code can be quite challenging to understand if you don't know it, but also it's quite hard to learn because remember that for machine code you've got to understand binary and a lot of codes which probably aren't going to mean much to you. Rather than us having to remember those different codes, we've come up with a set of assembly language codes. These commands are called mnemonics. So basically simple memory aids which we can use which automatically create a set of machine code binary. So assembly language is still quite difficult to learn, and that's why obviously we developed high-level languages, but it gives us the more ability to actually store and process data in the CPU. So as I said already, high-level languages are programming languages you'll recognise and can be easily understood by a programmer, such as Java and C. We have clear syntax and keywords which represent things within the language. The key thing for a computer to use machine code, if you're programming in human or high-level language, is using a translator. Now we're going to have a look a little bit more about the different types of translators on the next slide. This is a very light touch on what a translator is, because we go into a lot more detail about these different types of translators. Now, a translator is the overall name given to a piece of software which converts high-level languages or assembly code into machine code. And there are three types of these. There's the assembler. Now, this one is simple. It converts assembly language into machine code, or converts mnemonics into machine code. Compilers and interpreters tend to work with more high-level languages. Now, a compiler converts the whole code into a .exe file. This can be run on any computer. You don't need a certain piece of software to actually run it. However, it takes quite a long time to compile all the code. Imagine you have a large program and you've got to convert the whole code at one go. That might mean we have errors in the code that it doesn't pick up until we've actually compiled it all. There's also an interpreter. This does it line by line, so it converts a line of high-level code into machine code. So the program tends to run slowly, and on the computer where you're running the program, you actually need a copy of the interpreter. This can be a challenge for you to actually run a program on a computer where you've not got that software. However, it makes it a lot easier for you to find and fix problems. Because you're running it line by line, as soon as we hit a problem, you're going to be able to try and figure out what that problem is. So you should hopefully have an overview of what different programming languages are. So we're going to have a look at assembly language. Here's a bit of code. Pause the video and spend 20 seconds thinking what you think this code would actually do. So let's look at our spaces in RAM. It's a little bit like when we looked at the fetch, decode and execute cycle. In our RAM we have some different memory locations. Memory location 4, memory location 5, 6, 7, etc. And you can see I've put some data here in 4 and 5. The code on the left, INP, stands for input. So we're expecting an input from the user. So the first thing we're going to do is input, and then it says sta4. That means store in 4. So it's putting 17 into 4 for us. imp is another input. And then what we want to do is add 5. Now it doesn't mean add the number 5, it means add the value that is located in 5 and print that out. HLT stands for halt. Here are some basic assembly language codes for you. Remember we had a not code and an operand. These are some of the codes. So you'd have sta, store, lda, load, out is output the number, so that's outputting whatever's in the accumulator notice. Add x is adding x to the value that's in the accumulator. Sub x is subtracting x, and halt is to end the program. I want you to look at the worksheet that is attached to this unit and complete the different tasks. You now need to watch the video on RISC and CISC, the Craig and Dave video, which is linked in this bundle of work, and we'll be looking at RISC and CISC next lesson.